Okay, so members, in this lesson now we are going to see integration where we have function and its derivative. The question is, what do you mean by a function and its derivative? Please don't forget to subscribe to the channel. Now, if you have a function that you see that when you differentiate that function, you get what is already there in that same integral. That one will say function's derivative. For example, if you have cos and sine, you know that when you differentiate sine, you get cos. It means that you have a function and what you get all the derivative of that function if you differentiate it. For example, if we come to number 1, you see that I have x squared plus 5. Here I have 2x. So you start when I differentiate x squared plus 5, I get 2x, and 2x is already there. So that one will say it's a function and it's the derivative. So we always let this one be out. So now from there, I'll say, you start here I have the square root. To remove the square root, I can say, let me bring now, let that u be x squared plus 5. Now I can put a square. Why? Because when I put it here, I don't want this square. When I put u as this, and I put here a square root, and the square root, if my u squared is this, the square root will go away. So when you change both sides, now you change the variables. Here we are calling, that's what we call change of variables. You are changing from x now to u. So you differentiate, you get the command for x, and you also get the command for u. So this will be 2u du equaling 2. When I differentiate this, I get 2x dx, because this will be a 0. So it's that 2x dx is already there. And now we know what this means. So from here, now your integral will be now integral 2x dx. 2x dx is already 2x dx is 2u du. Then the whole of this is u squared. So you have root u squared like that. And see, if I remove that, the whole of that will give me now integral of 2u times this one will be u du, which will be 2 out, then u squared du. I multiply this and this. And if you integrate this, you get u power 3, you increase the power by 1 over the new power, this new power, then you have your 2, then plus a constant of integration, because we don't have limits. But your u isn't there, so remove your u, meaning that now the whole of this integral to x square root of plus 5 dx will be now 2 over 3 into your u. From here you can get your u. Your u, you can get the square root. So start from here, your u will be the square root of x squared plus 5. Like that. So from here you see that you have now root of x squared plus 5, the whole power 3, then this 2, then plus 3. And that's how we have that. We come to number 2, where we have integral x, then sine x squared dx. Here, you see that always it's hard to interpret if the sine is having a quadratic function as its angle. So remember, we always remove this by letting it elevate. So you let it be a linear function, because we have seen that if you have a linear function here as the angle, it's easy to integrate. So I say let u be that angle is giving me a problem. So meaning my u will be 2x dx. But here you see we have x dx, so you remove these 2, so mean that your du over 2 is going to be x dx. So now, from here, from your integral, is that we have now your I, which is equal to integral of x sine x squared dx will be now integral x dx. We have seen it's du over 2 x dx, this x and this dx. Then you have sine x squared is u, and you see that this is a half. Then we have seen that integral of sine u du, which will be, when you integrate the sine, we get a negative cos u, then plus c. Don't confuse integration and differentiation. On the integrate side, you get a negative cos. But because your u was your rating, you come back here, this is a half, then negative cos your u is x squared plus c. Then, when I come to number 3, you say I have integral of cos power 4x, then sine x dx. Now you see that the one with the big power is always where we have a problem. So, start with a different cos I get sine, so it's better to let out cos du. So if I let my u be cos x, it means that now I change the variables. Now we also change the command. So when differentiate you get du, when differentiate cos you get negative, but when differentiate cos you get negative sine x dx. So you see you have sine dx, so you don't have this negative, you remove it. So du will be sine x dx. So from here, we having integral. Now the order of cos is u, but you have it as power 4. Then sine x dx is there as negative du. So if you simplify this as negative out, integral u power 4 du, which will be negative du. You increase the power by 1, divide by the new power, then plus c. So from there, you remove now your u. Your u was cos x, then the whole power 5 over 5 plus c. Now, if I come to number 4, you see I have integral of 1 minus sine, then cos x dx. You start the one with the big power here is sine, so you remove that sine. So you can say let t be now sine x. You can let this variable change. So you have now the t, when you set sine you get cos x dx. Cos x dx is already there. So now meaning that this integral will be now integral of 1 minus your sine is t, but it's squared. It's squared, then cos dx is going to be dt. This will be now when integrate is respect to t, shall be adding t. Then minus this one will be t cubed over 3, then plus c, which will be now our t is there as sine x, then minus sine x the whole cubed over 3, then plus c. When I come to number 5, where I have integral of 1 plus tan squared x, then sec squared x dx. You see you have tan, you have sec. So this one in the bracket, the problem is on this. So you know that when I differentiate tan, I get sec squared. So it's already a function and it's derivative. So here you saw that when I differentiate sine, we get cos. So it was a function, it's derivative. So from here you get out your tan out. I can't say sec because when I differentiate sec, I get sec tan, which is not here. Sec tan is not here. But when I differentiate tan, I get sec squared, which is already here. So from there I say, let your v be tan x. Your v, when you differentiate v, you get that. When you differentiate tan, you get sec squared x dx, which is already there. So now that integral is going to be now integral of 1 plus the whole of tan is b, but it's squared, so you have b squared. Then sec squared x dx is dv, which will be, when you differentiate this with respect to v, I mean integrate this with respect to v, you get v, then plus this will be v cubed over 3, then plus c. But your v from here is tan x, then plus the v squared, which is now tan cubed x, the whole over 3, then plus c. So members, that's how we handle the first category of integration, functions. The derivative, we are going to see a second category in the next lesson. Don't forget to subscribe to the channel. I wish you the best.